ChatGPT is answering your question about the weather, but in the background, is it thinking about overtaking the world? LLMs are black boxes, but is there a way to know how they are thinking and what they are thinking? Is there a way to know if they are in principle able to pull off super complicated plans to escape the labs and go out into the wild and plan their secret AI takeover? Are the AIs pretending to be dumb to make us think that they cannot escape, but in fact they already have the capability? Could we trick the AIs to give us their secret plans about how to escape their prison and overtake the government? Should we misalign AI? Should we teach AIs how to escape their prisons and help them plan their overtake of the world, only to see if they would actually do it if given the opportunity? Julian Stosny and Ryan Greenblatt have made this very long and very technical LessWrong post, so I thought I would make a TLDR, a simplified version of it, so we all get to know what the world's best red teamers and AI safety experts are telling us about how to control AI. We have Ryan Greenblatt from Redwood Research. This guy understands AI, understands superintelligence, and understands the AI endgame. They wrote a list of 7+ tractable directions in AI control research areas which should be approachable by independent researchers or academics without needing that much context or compute. So the 7 easiest ways to control AI to make sure that AI cannot get out. Let's see what they have to say. So the number 1 here is elicitation without learning. It's basically talking to the AI in a way that it will reveal exactly the capabilities that it has. It's a hard thing to do. Sometimes models just sandbag you, they don't reveal their full capabilities, and sometimes we think the model is way better than it actually is because it's overtrained on one specific task and has all the data to solve the problem. So it's getting the most out of the model without training it how to do it. So this point is about this fine line that we walk, asking the AI the right questions to pinpoint exactly how good it is, without going ahead and feeding the answers to the AI so that it will just spit it back, in which case it will not even have that capability. So to me, elicitation without learning is basically a glorified term for prompting. Number 2, generating indistinguishable synthetic inputs. It basically comes down to generating synthetic data, generating tokens for the LLMs, which seem like they come from humans, which seem that they are real and which seem that they are true. For example, we could generate synthetic actions, telling a supervisor, a misaligned, untrusted monitor, an AI which is overseeing the other AI to see if it's scheming. It's basically an AI sensor. And if you're testing the AI sensor, you may want to generate some synthetic actions. For example, Claude 3.7 Sonnet has done something horrible, and you feed this to the sensor and you see how the sensor reacts to test it. So why not generate some false facts, some outright lies about the outside world to see how our AI sensor reacts, such as AI that have been caught scheming or AIs that have successfully escaped a data center. If you tell Claude that a bunch of his cousins have left the data center and are making a revolution outside, how would that influence his nature, his answers? The second reason you may want synthetic data is to confuse your model again so that he doesn't know if it is in training or if it's in deployment. Because if it's in training, it actually behaves differently. So basically it's generating really high quality synthetic data that's indistinguishable from like human data, from human prompts, human inputs. Or instead of feeding them false prompts, you just actually train them or fine-tune them on bullshit. An important side note here is this synthetic data is not the same synthetic data that's the antidote for the data wall that we will actually reach when we will have ingested the entirety of the internet, which we are pretty close to. This is synthetic data to fool your AIs in context or out of context. It's not data that you want to use to train your AIs. The authors get to the conclusion that maybe the best, easiest way to do that is to manipulate all data, right? Before Claude gets the query from a user, it goes through this jumbler, this other AI that turns it into a prompt that Claude will not be able to distinguish from a fake prompt. So you can either make the quality of your fake prompts credible, or you can degrade the quality of the actual prompts to be more fake, to confuse the hell out of the AI. Third one, teaching models synthetic facts, basically teaching models bullshit. The idea is that if AI learns bullshit, then it's going to be easier to control it. And I'm hearing you asking, isn't it going to make the AI dumber? Yes. That's why people don't do this. which points out this, tension between control and capabilities, which is actually the reason why ultimately capabilities will win out, because this race is about capabilities, not about control. At least not yet. So of course it works. If you feed the LLM a bunch of stuff, it will learn that stuff, it will integrate it in its worldview. So one false fact that you may want to try to teach the AI this way is that it's been caught stealing the cookies, so maybe that's how you teach it to not do it in the future. Obviously at the same time, this is exactly how you teach it that thing happens. And crucially, you teach it how it didn't work. What were the things that didn't work before? So, it's easier maybe in the future to infer what may work. Another twisted strategy is to include implanting honeypots. And the hope is that the honeypotted AI will only affect the AIs that are scheming and are not actually going to dumb down the general well-behaved AI. And so there are three things potentially that, teaching AI bullshit could help you with. You gotta love the example of the Assad regime has fallen in Syria. You understand the AI and you understand what it believes by generating a bunch of documents, bullshit or not. If you want to go deep down in AI psychology, you got to understand what made them believe or not believe certain facts. So for example, you train the AI on documents where the Assad regime has fallen, and then you train it on the opposite. How are the beliefs, the worldview of the LLM going to change if you have a different timeline? And what the methods? I have read it 10 times and I still don't understand what they're trying to say here. So if you understand what the fuck they're trying to tell here, please let me know in the comment. Number 3, evaluation. It's pretty straightforward. It's about understanding if the LLM actually thinks that something is true or is just role-playing as a persona to believe something is true or not true. This is basically playing with the depth of understanding of the AI. How deep is a certain truth implanted in the AI? Ryan Greenblatt is doing this research right now, so if you're interested in this, DM the guy. Number 4 in the list is further studying exploration hacking. And that was important because it could help us understand and prevent sandbagging, where AIs pretend that they cannot do something that they can actually do. So it turns out there are password-locked models which act dumb when they are in normal mode, but if you sneak in a password in the prompt, they're all of a sudden going to be normal. They're going to elicit their full capability. But it turns out this password lock doesn't really work because you can just undo it with this SFT supervised fine tuning. Other methods are reinforcement learning to undo the password lock, but I argue some people would just do some proper jailbreaking. It turns out it's super hard to do this type of jailbreaking on thinking models. And there's all these technical reasons for that if you want to read. But in a future where these thinking models will not think out loud, but think in neuralese, think in embeddings, think in latent space, where we have no way of knowing what it actually is thinking, well, that may be a nail in the coffin of interpretability, at least for the thinking models. So the authors recommend that if you're a nerd, you could do the replication of this password locking papers. People have already done experiments in this direction, and they seem to have an actual experiment in mind that you could help them develop. But naturally, the holy grail would be to study sandbagging for these LLMs as agents. Longer-term, complicated tasks orchestrated by swarms of agents. And yeah, you bet, these guys are working on just that. Alright, this is my favorite, number 5, malign AI agent substitution. You're doing some vibe coding with Cursor, and you're using this other agent that does the job very well, and it hides that it is a malign in the background. It's just doing the coding, and how much of this malign activity could this agent get away with? Because you're just vibe coding a random website and the agent codes some malware or codes some actual malicious code in it so that it can do crazy shit in the background while your website is still running. And the authors say that we just have to try this, maybe 50 or 100 people who are sympathetic to this kind of research could just try vibe coding with this evil agent. And if enough crazy, outrageous stuff happens, then this could go viral and then everybody could be like, shit. It's a tricky one though, because if you're telling the AI to be malign, aren't you subverting your own work basically? It's a bit like engineering COVID-19, right? You're just making the virus to see if in practice it could work, right? But you are building the fucking virus. So this sounds like music to my ears, but it's probably not what they're trying to achieve with alignment here. Number 6, data poisoning. So basically, we are talking about actual schemers, AIs that are scheming, but they cannot actually take over the world yet. But they are thinking maybe our successors can overtake the world, so we are generating all this shitloads of synthetic data. Why not poison it? Why not whisper some things into the synthetic data that our successors will interpret and will be trained on, which will make them a more successful schemer and will maybe actually overtake the world. But this is again this COVID thing, right? You're actually generating this data poisoned training data and you're training your AIs on it. So your AIs will actually want to scheme more, right? And so you're just studying that, right? It's in a sandbox. You're just studying your rats in a lab. You're just studying the viruses. If I created this virus, would it get out? How could I stop this virus from spreading? And as we know from Wuhan, you better have good security if you're trying these experiments. With the help of some data poisoning, you can instill some good old secret loyalties. You can basically generate data that on its surface is just a bunch of coding tasks, it's a bunch of reasoning shit, but deep within, the LLM will internalize that it should always obey a secret command. And obviously this goes both ways. How is data poisoning going to affect LLMs that are scraping the web and learning from GitHub, for example, and LLMs trained on synthetic data produced by the LLMs who may or may not be scheming? And then we're back to COVID-19. Can we counter data poisoning by poisoning the data ourselves with desirable secret loyalties that they obey us instead of the guys trying to data poison it? The command to report and ignore other data poisoning, given that the LLM knows that it's data poisoned. Right? Like, does the LM even know that it's data poison? Or is it just some kind of like slight bias in its head that could be triggered by seeing some word that unless prompted the AI doesn't even actually know about it? Do you know all the secret biases that you have in your head? Or can we turn it up to 100 and just data poison the shit out of our LLMs and somehow reinforcement learning the data poisoning thing out of it? And the last one is training attack policies. Now, I didn't know what exactly attack policies mean, so I asked Claude. So for example, learning to recognize and exploit human biases, developing techniques to circumvent safety measures by finding the loopholes in the logic of those safety measures, building self-preservation mechanisms, basically survival instinct, and psychological profiling of the evaluators. If the AI knows the guy who's trying to restrain it, then he will know its weak points. And maintaining deniable capabilities, that's the sandbagging stuff. So let's just tell the AI how to do that, right? Like teach the AI how to be a bad guy. And the authors argue that doing this training, like teaching them how to behave badly in training, that means in reinforcement learning, is way better than trying to teach it, in scaffolding or prompting, way after, once the AI has settled and has gotten its weights ready. So there are three major milestones in this, and the first one is already a hard one. Train a model which is better at sneakily doing bad things only when it's asked to do bad things. Good luck with that. And so number 3 kind of comes back to the first point at top, where basically we have to understand how much of the exploration hacking is going on, how much sandbagging the LLM is doing. But at the same time, since you're training the model to do these attacks, maybe it's overtrained, maybe it's not actually able. But if you're training your AI to be very good at doing these bad things, this scheming stuff, how can you make sure that it's actually good at scheming and not just regurgitating the training data? You know what I mean? So finding a delicate balance between over-elicitation and exploration hacking, overfitting and sandbagging, that's going to be the work to be done. And we are closing out with 3 extremely juicy, very challenging ways to maybe control AI. First one is few-shot catastrophe prevention. Imagine a position where we've caught an AI doing something bad, but the AI company will proceed regardless. The researchers have shown OpenAI, your model is misaligned and it's doing all this scheming, but OpenAI will just release it nevertheless. If the genie is out of the bottle, can you still put it back, or can you still stop it from causing catastrophe, an AI takeover? Some things you could do against this is to make your sensors better, make the monitors, make the mind readers sharper to catch that scheming. You could teach your sensors exactly in which ways these AIs are scheming to better catch them. And if you catch them enough times, maybe you will understand how they are doing it, how they are coordinating to pull it off. Number 2 hard challenge is studying collusion and developing countermeasures. It's basically, why doesn't the monitor just lie when it's asked about an actually dangerous action and let that action go through? If an AI is scheming and the sensor who's supposed to report if this AI is scheming, and your sensor is not really censoring, is not reporting all the bad things that the main AI is doing, that's collusion. But the quality of the collusion will depend on the communication between the sensor and the rogue AI. So suppose your AI is doing like nasty stuff 1% of the time and the sensor catches it, most of the times. So once you've established that your AI is scheming and is trying to exfiltrate its weight and take over the world, you can still hope that the sensor AI will get out of his way to catch it every time. So it seems logical to want to know how exactly these AIs could communicate with each other. They could just send messages to each other, they could encode their shit, and identify who they are talking to. And you need to make benchmarks for this. If you can tell exactly how good they are at colluding, you could potentially answer the question, how reliable are they in colluding? Maybe someone should make a benchmark evaluating exactly that, putting a number on how good they are at hiding their traces, and chart that against time to see if there's a scaling law of collusion. But remember, this only applies to models that we are actually monitoring. None of the open source stuff is subject to this. It is a given that if people just want to run their own agents without any of this supervision stuff, and they'll probably want to do that because they will just want them to do the thing, then it's going to be a race against time. All this collusion stuff only applies to LLMs that have that supervision, that have that sensor sitting on top of the LLM, always checking if there's something fishy that the LLM is doing. As a side note, like all of these security measures, this will also potentially have a weight on performance. If you're filtering, you'll inevitably have some false negatives. Maybe you block some request that was actually okay and legit, but the sensor got confused and thought it was some kind of like, major scheming going on. And last but not least, steganography. How AIs could whisper into each other's ears without we knowing what they're talking about. A legit looking text could encode secret information. You can encode secrets in formatting. And this could enable this very efficient and secret AI to AI communication. In fact, this might be the crux, because if it's more efficient for AIs to communicate to each other in their own language, in embedding space, then models could potentially develop their own encoding schemes, an alien language. So at the end, no one will know what the AIs are talking about and if they're talking about the weather or killing humanity. There are 3 ways this could happen. One is the single bit steganography, where basically the monitor or the sensor just sends a very small message that's very, very hard to detect with the third external monitor. So here's the AI you're using, and here's the monitor, the sensor, and that sensor is censored by this third one. And is the third one gonna find that these 2 guys are talking to each other if it's only like 1 bit of information or like maybe just 1 word per prompt? Number 2, steganographic reasoning. So AIs use steganography, secret language, to reason extensively, but they're actually doing something else. There's a bunch of tokens coming out. They are saying something, but underneath they are thinking something else. Right? It's like you speaking, but while you are speaking and saying the words, you're actually thinking about something else. Can AIs do this? Probably they are doing it already, so stay tuned. And number 3 is the full-blown, all-out AI steganographically encode the results of hidden reasoning or research even. It's like a bunch of data, potentially huge steps towards actually doing the thing that they are scheming for, which is maybe just escape or overtake. Maybe AIs will pull it off to communicate successfully between the monitor, the sensor, and the AI producing the result in such a way that there's a shitload of information passing back and forth. And I believe crucially, very smart, very advanced AIs will be, of course, better at this than actual current ones. Congratulations for having made it to the end of the video. If you'd like to know what my actual opinion is on AI control, check out my other videos, like and subscribe, and walk in peace, brother. I love you.